Hi, uh, everyone that's joining us right now. This is our first virtual roundtable. This one is going to be brought to you because of troubleshooting issues that we've had in the past. So what I've done is I've invited some subject matter experts to come on as panelists today. So to kind of go through and get this thing started. To stay in the know, if something happens, I know a lot of y'all might be at work, working remotely, kids might walk in, internet might go out. So if you have anything in particular, reach back out to us, but we are going to put this video up on our website and with a transcript, so that way you can do a quick search find if you're looking for something in particular. Meeting the speakers. So my name is Cameron Croft. I'm CEO of Croft Production Systems. I'm just going to act as moderator. I got enough smart people on this. I can just go with them. But we have Chris Smithson joining us, Director of Engineering for Croft Production Systems. We have Jesse Oliveras, CEO of Osynergy, which is a manufacturing facility. Back in for him is manufacturing, production, processing equipment, pressure vessels, and he's done a lot of design work for the oil and gas and private sector, or construction, civil. We have Terry Nelson with WPI, Waukesha Pierce. He's manager in technical services, focusing on glycol systems, production equipment, processing equipment. Coming from his background, really focusing into the glycol systems. He has seminars that he puts on, and then all three of these speakers were able to join us today. So we'll get started with them. The topic highlights that we wanted to discuss. Now, we do have some questions that were given to us beforehand, but we were wanting to go over glycol dehydration, solid desiccant dehydration, amine plants, JT plants, and fuel gas. But these are just topics. If there's something in particular that y'all really want to discuss about, we're just going to let this conversation go with that. So how this is going to work is, if you got a question, specific question, y'all can write it in the chat box or the question Q&A answer section. If y'all want to discuss it, you can write it in. But if you say, hey, I have a question, once it gets to you, I'm going to unmute you. So that way you can actually just start talking with the subject matter experts. We're going to have one person take the lead. So in this case, it might be Terry Nelson. He'll take the lead over the question, start answering. And then once he's going in, Jesse or Chris might come in, follow up if there's any gap or some things that they want to add to the question. So we're going to get started now. I'm going to stop sharing so that way we can see everybody's faces. So again, if you have a question and answer, y'all can type it into the chat, type it into the Q&A section, and then that way we can kind of get started with this. But the people, there's a lot of questions that were shipped in beforehand. So what I want to first go over, Chris, if you can kick us off. The question was fuel gas for compressors. What are some quick tips to maintain fuel gas composition to prevent compressor shutdown?
So really, you're gonna have to look at your fuel skid and where you're pulling your fuel gas from for the, a way to make sure that you're getting the best quality that you can. If it's coming after process equipment, or if there is process equipment and you're not coming after it, like let's say you have a dehy on location, and for some reason you're choosing to not pull after that dehy, that's a quick move that you can, pull from after the processing equipment to get a little better quality gas, making sure you're pulling after, all available separation so that you're not getting, gas that may have any sort of condensate. Just being considerate of what the temperature changes, especially if you have rich gas, if there's a temperature effect changes that are happening, like if you have a long pipe run between where you're pulling the gas and then your actual compressor, are you seeing temperature changes happening there? That's a good way to make sure you're not going to have condensate problem falling out. But really, if you are having condensate issues, a proper fuel gas skid is really the only way to make sure that you can run throughout most of the year without any problems.
So a proper fuel gas skid, I made a JT plant, regulator on a separator.
Yeah, I mean, you can make them work. Use a regulator with some separation. It really depends on the quality of the gas that you have. I mean, if you have rich gas, you're going to want a JT unit, something that's going to warm the gas back up again with the heat exchangers. So you're gonna, that'll give you a much better quality because you're going to actually lower the BTU and have a much bigger hydrocarbon dew point depression with the gas, with the JT unit, than you will just a fuel skid. If the gas is pretty clean, then you can get away with just a dehy and a regulator. Dehy in the gas can be a big improvement, as Terry can attest. I mean, a glycol unit can do pretty good at taking condensate out of a line. It'll suck it up and hopefully get separated out in the regenerator. So, having clean, dry fuel gas can really help and get rid of a lot of the problems that you may see with your fuel gas.
That's good. Jesse or Terry, did you have anything to add to that?
Well, he pretty much covered everything that was in my mind. Of course, when you look at the fuel gas, the dehy is downstream of the compressor, especially when you're looking in gas lift situations. At a lot of locations now, they're using a dehy to dry the gas before they send it down the wellbore for lifting mechanism. So the dehy has to be critical because of hydrate formation. If we don't process the gas, both, like you say, upstream or a dehy unit drying the moisture out before we send it down the well, then you're going to have hydrate formation and you're going to freeze off, and that's going to cause back pressure, and that's going to shut everything. A lot of the downtime that the Permian and Delaware is facing now on gas lift is directly kicked back to the dehy units, and that's shutting compressors in.
And if you are gas lifting, then most likely you do have rich gas because you're trying to use the gas lift to lift the liquids out of the well. And we've definitely seen that with gas lift sites. I mean, if they don't have process equipment, if they're not drying it, they're risking freezing up their gas lift valves. But also, it does make it difficult to use that gas on the location for fuel and instrumentation and burners and anything else you have, because the richer the gas, the more the higher the temperature that you could have a hydrate in. So it's more critical to dry richer gas than it is leaner gas, because your hydrate, the theoretical prediction for hydrates is warmer the richer the gas is.
That's good. Well, so we had a few people join us. If you are joining us right now, we're going through some pre-prompt questions, but if you all have any specific questions that you have, just write them in the Q&A section or in the chat, and then we're going to let you try to unmute you so that way you are allowed to talk and kind of go through the issues that you're having. So if you got any specific production processing issues, just let us know. All right, so the second question I got is, Jesse, actually, I think this will pertain to you. They wrote, "What am I getting with NACE vessels? Is it worth it?" So,
well, with the NACE process, really what you're getting is a product that meets certain requirements. In this case, especially if you're dealing with any H2S or sour gas, then it's going to help you in the long run. I mean, it might cost you more at the beginning for capital costs, but you're basically ensuring that you're not going to have stress cracking, which eventually we've seen it where it's, you have cracks, you'll have basically leaks, which then you're going to have downtime, you're going to have repairs, etc. Now, most of the materials, especially on smaller sizes, are already dual spec, right? So they're already good for NACE, so you're not really adding any additional cost there. Is it worth it? In my opinion, it absolutely is if you have those conditions. If you don't, and it's larger, especially let's say pressure vessels, then you'll save some money by not requesting the NACE. Now, one of the things that I like to ask is, you have NACE, and then to me, it depends on the level of solar service. I mean, some people you could get basically threaded piping and fittings and need NACE, but if you have high H2S, and I would recommend it, I would go all flange and so forth. So at the end, it is worth meeting your NACE requirements. You're going to have, it's going to save you a lot of downtime and headaches down the road. Some of the things that are overlooked are probably in the instrument side, where they say, okay, yeah, it meets NACE, but if you didn't order your instruments to have your seals and gaskets and so forth to meet NACE, then those are going to go out. The other part is the welding side. If you didn't have a qualified procedure to meet NACE requirements, then your materials are going to be great, but you're going to have failures at your weld. So those are just some of the things to also look at when you're looking at NACE. It depends. Flange materials is going to cost a lot more than threaded. So those are all things you have to ask yourself at what point do you want to go from, non-NACE to NACE threaded to, NACE flange materials. So, I think it's very well worth it to look at those and go NACE if you require.
Yeah, Chris, did you have anything to follow up on that? I know you're dealing with some NACE and some proposals for NACE right now.
Yeah, we've gotten requests in for it before. I know one thing the clients try to do is they want to try to dehy. Well, I've heard they think it'll work, but they say, if we dehy the gas, then if you get rid of the water, then you don't have the corrosion issue anymore with H2S. So they're like, it's like 10,000 ppm H2S. As long as it's dry, then you'll get rid of a lot of that corrosion issues with it, which that's not, for one of the mechanisms of H2S corrosion, that is true. But for like what Jesse was saying with the stress cracking, that's not a water dependent corrosion issue. I would be curious to hear, Terry, if you have some input on, have you run real sour service dehys in the past? I mean, a trade tower, to me, we've seen them in H2S service. They're the units that have been in H2S service, not operational, so I'm not really sure about that, but I couldn't really imagine running a glycol unit in H2S service, trying to keep that thing operational for more than a year or two.
Well, that's actually the follow-up question they had, is work with any NACE glycol systems. What are the areas of concern?
Well, I've actually built a completely stainless steel dehy before because a customer just wanted to go to that extreme. We actually suggested that they limit, they go to NACE controls, and you can buy pumps and different things that meet those standards. But as far as like the reboiler shell and all that stuff, it's not really necessary. It just depends on how far you want to go. Most customers, when they go down this road, like Jesse said, they deal with the connections, the valves and regulators, making sure all that meets the standard. And then they'll go with maybe a stainless steel fire tube. Because when you look at a dehy system, that's where the corrosion occurs. That's where the temperature is. That's where the gas meets the glycol. And usually where the liquid stops and the vapor stage starts, that's where the corrosion occurs. Because that's where the air is present or the gas is present, and the corrosive line usually follows the liquid level line. So a lot of people want to do a stainless steel fire tube. I've done stainless steel columns because the escaping steam gets corrosive sometimes in that atmosphere. Mm-hmm. The most important thing is to look at it with common sense and just don't dive into it and build something that's cost prohibitive to really what your concerns are. The biggest problems is where you have dissimilar metals meeting. Mm-hmm. If you build a stainless steel fire tube, then you better build a stainless steel tube sheet. Because if you take a carbon steel tube sheet, right, weld a stainless steel fire tube on it, and that's what happens sometimes, then the corrosion will occur where those dissimilar metals are meeting. And that's usually the problems that happen. But you can go as far as you wanted to when you start diving into that. But most of the time you need to get with an engineer, design engineer, somebody like Chris or Jesse, or just somebody to pull you back in from the ledge and speak, you know, in good common terms.
Either he stopped or he's very good at holding still.
Froze a little bit.
Well, Terry was bringing up some really good points. The fact of just understanding what the customer's going to need at the end. I mean, nowadays, especially with cost, right? We're all looking at how do we reduce cost. Of course, we balance cost with the actually safe side of a design, right? So, you know, we have not built an all stainless DI unit, but we have had a combination. One of the other things we've done is we've done internal coating, you know, help reduce, maybe not, if they don't want to go to the stainless steel level, you internal coat and add at least another layer of protection. But we got a little thicker on the metals, you know, knowing that you'll have some corrosion and loss of metal. So that might be another option when you're trying to balance cost and the H2S side of it, or the solid environment side of it. On the similar weld material, you know, obviously you have to have, that's why you qualify your procedure to be able to do, you know, meet solid service, send the testing, and make sure it's able to handle that.
So what about cladding vessels, Jesse, like stainless steel cladding internally? Is that cost effective at all for, you know, trying to get some extra corrosion protection?
Well, we don't really have that capabilities, and I have some experience on it. You know, it's an option. I have not seen it very often, to be honest with you. I think at the end is, you know, you either go thicker on your metal or you go with the other option. Now, I believe the bigger you go, that would make sense, you know, just because it's going to be a lot thicker and a lot more cost to build just by changing the material spec on it.
Well, we actually had one question come up. So this is our first live question. So I'd like to kind of put some priority onto it. This is, I think this is a manufacturer. Would a SMIC turbulator help in reducing hot spots in fire tubes? Is that a manufacturer, or did they just type really quickly?
Um,
I guess
Did I just
a Terry
for
question.
a few minutes?
Yeah.
Okay. I've actually moved more turbulators than I have installed.
really.
Yeah, back in the 80s, early 90s, turbulators were the thing. And we would install them on the downstream side of a fire tube. And it was just there to expand surface area. Great idea when you think about it, but it's also a good trap to catch stuff, soot and different items. And it was a vibration point. Vibration means wear.
Mm-hmm. And
we had fire tube damages because of it. Now, it could have just been the design of the turbulators. At those times, they were honeycomb, 8 or 10 feet long, and it was just designed that heat, something to bounce off of in the downstream side of a fire tube. Now, we all know that flame impingement is bad, and that's when a burner is not dead center and it's causing the flame to actually run down the fire tube wall. That's with an eclipse style burner. That's never good. You want the burner in an eclipse style burner going dead center down the fire tube and expanding heat out. Now, when you look at the Clear Rush or Gold Rush, or there's 4 or 5 manufacturers that make these inserts into burners, and they actually close off the fire tube, and you have little vents you open up, little fins, and then it has a different style of burner that operates at 3 to 5 pounds of pressure. Those burners are designed to create a swirling effect, and that's causing the flame to swirl around the fire tube as it goes down the fire tube. That's a different philosophy an actual flame running down the tube wall. So a turbulator, what a turbulator is just a way to expand the surface area of the fire tubes to get more time for it to stay in the fire tube before the heat is lost out the stack. We never want high stack temperature. We want high fire tube temperature. When you have a high temperature, anything 650, 700, then you're losing BTUs out the stack. And a turbulator is a great philosophy of slowing down that process because that burner's natural draft. If we can slow that down, but it has to be designed just right, because if you got too much, then you're starving your system for air. So you have to be able to draft. So the turbulator design is critical, but they do work.
I think, like you said, though, like you've seen a lot of wear points, vibrations and stuff, and especially since, I mean, I'm sure like you get a harmonic sometimes with the way that the burner may start pulsing, and I'm sure that,
Yep.
vibrations with that, but a lot of burners, they're on off service. So that thing's constantly, if it's just something you slide into a fire tube, it's constantly expanding and contracting, which can cause wear points if it's not, welded every single point of that thing that's touching the fire tube. So yeah, some of the, I've seen some interesting designs for them. No one's ever wanted to pay for the upgrade for it, but in concept, it seems like a really good way to get a little extra fuel efficiency out, and that's really what you're getting with it is fuel efficiency. You're going to save some MCF on your burner system by squeezing that heat out of your stack temperature. But yeah, most of them are just slide-ins, and I wouldn't feel confident that's something that's going to last for a decade or more. That's just constantly rubbing on the inside of that fire tube. But we do use them in heat exchangers like the JT units. They are a good way to boost efficiency in like shell and tube exchangers, especially liquid exchangers. They can have a really good effect on the efficiency of a liquid exchanger. Cameron, you're muted.
Am I unmuted now?
There we go.
It was great. It was very eloquently, great etiquette, great enunciation of words.
Took me a second there. I wasn't sure if you got into the pretzels or something. I'm just chewing away.
Well, it could be. All right. Well, to follow up on the repair conversation, one of the follow-up questions we had, Jesse, if you don't mind to take over this one, it says, in your experience, what are the most repaired areas, contact tower failures, separator failures? And then they just wrote every equipment. But let's just say, let's just keep on with the glycols and separators. Like I know your company does a lot of repair work. So where do you see the most failures happening?
Oh, Jesse froze.
Well, by far, where we've had most of the repairs are around nozzles, whether they're in the liquid level or they're in the gas side, where it just has a corrosion point, whether they're in the inlet or you still have drains. By far, they're around, and especially around the well to nozzle connection. I mean, for whatever reason, I guess it's just either the wells was like we talked earlier, whether it was not really a NACE certified procedure, so therefore you have some stress cracking, or in this case some pinholes developing. But by far, that's it. The next level we've seen it is around the mist path. They get wore out. There's no cleaning. It has a lot of solids and stuff like that. So then we're having to go in there and cut the head and replace mist pads. Those really are the two major as far as separators on the towers. Again, nozzles are a big factor there. The other area we see is around the trays, whether we talked about on the previous webinar. We had a contactor where it was a quick fill the well and they had a leak, right? So around the well areas seem to be where most of the failures occur. It could be just a poor, well, in our opinion, but those seem to be more of it. We don't really see much of the other areas impacted. The shell might get a little bit of wore out and stuff, some pits and what have you. But a lot of that has to do mainly with the improper either cleaning, or it just stays like that for a long time, no maintenance or preventive maintenance. And that's where we've seen a lot more of the issues.
Okay, so if those are the kind of the key areas of failure that you see, I mean, Chris or Terry, what the follow up on that was like, how do we prevent that? How do operators try to increase the longevity before repair work needs to be done?
Well, we do regularly scheduled like UT exams. You have a predictive maintenance program that I've been on that soapbox for 25 years. We have to schedule downtime much better than unscheduled downtime. So when we can have somebody go out and do relief valve testing, regular maintenance, and then predictive maintenance, where we're doing things that are letting us see into the future. If you do UT testing, there's a reason why you put those little stickers on there that shows where you tested it and what the thickness was. If you go back and check that every so often on a scheduled basis, you can figure out where the waves are, where the fissures are going to be created. When gas and liquid flow along a vessel like a wave, and it's carbon steel, if once something starts following a pattern, it's like erosion at the beach. You're going to have some fissures develop, and sometimes gas will strike a particular piece of point in the vessel and then bounce off, and that's a wear point. And if we have regular maintenance and we do those UT exams, and there's some great companies out there that do a lot of other predictive kind of non-destructive testing on different vessels, where they can do UT combined with some bore scope and some other ways to check vessels. We do that when we pull fire tubes on glycol units. We inspect it, and then we see some pits. We UT those areas. We make a map of the fire tube, and we measure those points. So next time we see if it's getting worse. Mm-hmm. Because if we can catch that spot and make a repair, we don't necessarily have to replace the whole fire tube. We can make a repair and put it back in service, versus it gets a hole in it, glycol pours into the fire tube, and then it comes out the flame arrestor and onto the ground. Now we got soil remediation, we got unscheduled downtime, and much more expensive repairs.
Yeah, I think low pressure vessels are usually where we see the leaks on stuff. I mean, all the vessels we've hydroed over the years and seen like pinhole failures or something on, it's usually on, if it's a vessel failure, it's usually like the cheaper little fuel pots or the cheaper flash separators. Those are areas that, those units, they're so thin to begin with that they can risk wearing out and having corrosion, especially if they're put in a service that they're not really meant for. Like any H2S will just chew through those little fuel pots. And like Terry had some good info in the dehy presentation about like monitoring pH in glycol units and making sure that that's not eating away different areas of the system. It's pretty important. And filters can tell you a lot. If you have a glycol unit or an amine plant, something that has those filters, an analysis of what the filter is picking up. If you actually like cut one open and scrape it and send it off, I mean, if you have a bunch of iron and you're getting stuck in your filters, then you have a problem. And something's getting eaten away. So those like Terry was saying about preventative maintenance. I mean, you can learn a lot if you actually monitor and log it and see how things are changing over time. It can give you a really good indication about what's happening in that unit.
Someone asked me one time, "Where's all this iron coming from in my glycol sample?" Yes, it's a contact tower, it's a vessel wall, it's a fire tube. it's iron that used to be intact, but now is in liquid form.
Right.
That's right. Well, we actually we have one participant. When they were signing up, they come from a sand separator company. So dealing with sand separation, I imagine they have to deal with a lot of wear and tear. But Terry, I like what you were saying earlier about that predictive wear and tear, like all the points. Like, you know, these are gonna be the top points that will fail first because they handle the flow. They have the 180 turns.
Right.
So having that predictive, like, it just gave me a business idea on our side, because we handle a lot of lease fleet. So if you come back and you bring it and you say, we need to at least UT these points, see where they are, because if they're failing or if they're good, then most likely the unit's gonna be good. But if they're failing, we might as well just do a full check on all the system at that. More predictive, I guess, on our return equipment.
Yeah, there's preventative maintenance, you know, PMs, and then there's predictive maintenance. You're looking further down the road to where, in your situation, you can predict when you got to replace that piece of rental equipment before it fails on the customer's location.
Yeah.
And then it helps you manage your fleet.
Well, it's kind of in our, I mean, we sell equipment, but, you know, our lease fleet, we don't start making good money until years and years down the road. So if it doesn't last years and years down the road, we're just shooting ourselves in the foot. And that actually kind of goes into one of the questions that we had. Jesse, again, this is probably for you, but techniques for long-term storage of equipment. I guess they were talking about, I mean, you build equipment new and ship it off. I mean, you ship stuff all around the world. How do you properly, I guess, get it ready for shipping and long-term storage?
Well, I think one of the first questions is understanding whether it's going to be for long-term storage. Most of our stuff, by the time we complete it, I mean, they're getting used within a month, right? So it's short-term. For long-term, you're really going to have to prepare for it. I mean, you want to make sure all your threaded connections are greased and plugged. If you know, if you have flange connections, you want to be able to grease the face and make sure you cover it up. And then we like put in at least minimum 5 pounds up to, you know, 20 psi of nitrogen to make sure it stays without allowing any oxygen and so forth to get in there. Of course, all this is making sure up front that it's properly clean, it's dried up, there's no scaling, no solids or any of that kind of stuff. Because even when you do hydro, you still have some of those things that you have to worry about and make sure you dry it up and clean it up. So when you, I mean, when we ship stuff out, even the packaging needs to be right. So one of the first things we need to understand is whether it's going to be for long term or not. If it's long term, those are the basics. We want to make sure we protect even the coating. We like using pretty, you know, even when the customer says, hey, you know, just do an enamel coating, we're not much of that. You know, our experience with enamel coating, they don't last, they get pale real quick, so we like going with polyurethane. So I'm not sure if it's my internet connection now. I got a note on my screen that it was acting up. But that in general is what we tend to look for when we place it on whether it's a skidded vessel or not, or whether it's by itself. It's just how we support it. You know, if it's going to be sitting around for a long time, you don't want to put it on the ground, obviously. And then the metal to metal contacts is one of the biggest things you want to look out for, because you know, when it condensates, rains, moisture, all that kind of stuff, it gets trapped right there, and that's where you're going to have, you know, a lot of your corrosion points for just staying out there, right?
One of our biggest problems when I was manufacturing director in one of my previous lives was knowing we're shipping that from South Texas. Where's it going? You know, is it going to go to Pennsylvania and then sit there through a winter or two before it's used? We built some oil stabilizers one time that had heat exchanger bundles and collection headers on the outside of the vessel, and they were all insulated. So at some point, either hydrotest water or some flanges were left open and rain rained in them, filled those collection headers up with water. Then they set for 6 months through a complete winter cycle. So when we went to start the vessels up, of course, the ice had expanded and broken the headers, split them open. Nothing is more powerful than ice. And so it was under the insulation, so nobody knew. So when they went, 6 months later and that's where Jesse's point is, it short-term or long-term, they went to put gas to them. All of a sudden, why is this gas blowing everywhere? Because you have ruptures in the headers from setting through that freeze. So it's really important to know where it's going and how long it's going to set there, because there's things you can do to keep the damage from occurring.
Well, you were saying earlier about drying them out, getting the hydrotest water, because we've run into a few of those issues too, where you try to blow out as much of you pressure it up, even trying to get all that water out, but in some of the low spots, the water sits. How, Jesse, how do you go about because I imagine you have to follow your code that you're following, but how do you get rid of some of that stuff, the water? How do you pressure that out? Just air compressor to it, or?
Well, if you just put air compressor, even air, an air compressor still going to have moisture. So, you dry as much as you can, but you're still putting some moisture back in there. So the best thing is just having dry air. So, when you have to do that, you either have to have a dryer ahead of your air compressor to make sure that when you're blowing in there, it's actually dry air, or a desiccant, right? So you put something in front that's removing all the moisture so that the air going into your equipment is actually dry. The other way, of course, it's more expensive, would be trying to use some of these other airs, either nitrogen or so forth, to try to push it. Now, everybody does something a little bit different. You either could use a tool to measure what kind of moisture you have, or if you're blowing things through one end and out the other, you could put either in a rag and see how much moisture is still coming out of that rag. So it's just different ways that you can look at ensuring that whether it's already dry or not.
Yeah,
Those vessels, they can be tricky because they any sort of scaling or corrosion on the inside of the vessel, it can definitely hold water. It can be difficult to dry them out. We noticed that with our refurbs, that they're a little trickier to dry because of the texture of the insides can hold a lot more, and that can be tricky to dry out.
We do actually have procedures for short-term and long-term storage of vessels. I've got 4 or 5 vessels, complete dehy systems right now, that have been in storage for almost 4 years. We have nitrogen purge, as Jesse said, on them. We've got nitrogen bottles that are setting on site, and we have regulators holding pressure, and then they have to be inspected. You have to have somebody go check on them, make sure there's no leaks, make sure the nitrogen is in supply, it's not ran out, because it will leak. There's going to be leaks. So you have to check that stuff. You can't just plug a vessel, fill it with water, and count on it being stored. That's why Jesse's first thing he says, it's short-term or long-term. There are differences.
Well, and then we actually just had a follow-up question from Paul. He said, how would the team recommend cleaning a vessel and associated connections after service in high H2S environment? So I guess, Jesse, I know you deal with H2S. What would be the code on that? How would you clean that?
Well, by the time we received the vessel, we actually required that they would already be cleaned. And especially because some of these items, we don't know where they're coming from. Some of them might have even norm. So, you will have to check for all those things. But, in my, like Terry said, past life, probably doing like a caustic wash or something of that sort to actually remove. One of the biggest thing is all this tends to trap along the wall of the vessel. So even when you think you already cleaned it and so forth, if you're not doing any kind of a sniff test and so forth, as soon as you start cutting anything, if you want to work on it, for example, that all starts coming out. So you get all those fumes out and what have you. So I would, my opinion would probably be like a caustic wash of some sort. Terry probably has better ideas on that.
We use a soda ash. You know, we do acid flushes where we actually go out and clean vessels with a chemical cleaning. Then we follow it with a muriatic acid mixture. And in an H2S situation, we would take our hoppers and add some soda ash to the circulating water, and that would cause it and bring it down out of the acidic range and bring it down. We also have to mix that soda ash with the solution that we're cleaning when there's H2S or when we're using an acid, so the vacuum trucks can actually receive the wastewater. We have to neutralize it. So we do the same thing.
Yeah, we do soda ash cleanouts on our little amine plants when we bring them back. Before we take them out of service, we'll yank all the amine and do a soda ash water mix. With H2S, certain amounts of it can actually be protective to the steel. It creates a protective coating on the inside of the plant, and the soda ash wash will actually get rid of that. But once you start taking that coating away, you can liberate out some H2S from that. If it was like an H2S removal unit, like our chemical injection systems where they're like real high H2S amounts in there, we water washing. If it was used for gas service water washing, it's good. Letting it sit in the water can help to get some breakout. It will absorb some of that H2S in there, but we've done it where we just take the leftover scavenger and wash it through with that, and the scavenger will help to grab some of that H2S. It'll kind of coat the insides of the vessel and get in there. But like Jesse was saying, it's tricky. If you start heating it up, you start putting a torch to it to preheat or start cutting things, I mean, you start liberating all sorts of gases out of there. We have if we ever have to cut on stuff, we're always got the sniffer out, and it was just tricky because the sniffer is only, like most of the handheld ones, they're measuring what's not oxygen. So it's not necessarily a good test to tell you, you got to have the H2S monitor, 4-gas monitor, something that's going to get methane. But yeah, it's tricky because as soon as you start heating things up, you can get all sorts of stuff falling out of it. And then whatever you washed it out with, let's say you do a water wash on it, that water, if you let it sit in a tank or something, it may start off-gassing H2S that it picked up if it starts heating up again. So it can be a little tricky to clean those out.
Well, on the flanges, he was talking about flanges in particular. Is there something that you wipe them down, something just before you put them in long-term storage after H2S?
Yeah, we probably we end up just cleaning them and then applying grease again and putting it back. I mean, it's like after you're doing the full wash already as it is, but we don't do nothing in addition to that wash, other than apply grease and make sure no corrosion is able to get back in there.
Well, I'm going to pop up a question on, all right. So Chris, they're doing all the hard work, so I'm going to finally give you a question that I think pertains to you more. It says they wrote quick tips for JT systems to operate better, kind of vague, but it says how to increase NGL recovery. So if you can just kind of talk about that a little bit. It seems like, yeah, go ahead.
I mean, JT units, I mean, it's all about that pressure temperature relation. So you want to get as cold as you can without dropping the pressure below the sweet spot for how you're trying to remove it. And it depends on the JT unit, the effectiveness of it. If you, the better the heat exchangers are, then your optimal pressure may be different than if you're just literally going through a regulator with the separator. There's usually the optimum pressure is going to be around like 275, 300 PSI. And that gives you a big enough drop down to and hold your cold separator at that to give you kind of like an optimum efficiency, but really it's temperature. And I mean, if you're taking your pressure drop down to 300 PSI from whatever it was, you're going to get as cold as you can. The next step would be, how do you decrease the temperature coming into the system so that you can get even colder on there without, you know, increasing your pressure if that's not an option. You know, how do you make the whole system overall get colder without going too low on your cold separator? And really it is that you know, finding that sweet spot. You know, maybe it's 250 psi in your cold separator. You know, it gives you that extra 5-10 degrees or something that's going to improve that recovery that you're going to get. But really you want to just try to get as cold without, you know, sacrificing that cold separator pressure, because you really need that optimum efficiency in your separation.
Well, on that, Terry or Jesse, do you have anything to follow up on that?
Well, you gotta make sure. Yeah, and I'm back. I think actually that was my fault. I clicked on something I shouldn't have clicked. But yeah, and like he said, you got to get that pressure drop. It's all about, you know, inlet and outlet pressure. So we got to be dry. We got to have our methanol going. Any freezing up in the JT valve trim is going to cause a problem. So we got to make sure we have that methanol injection going across the trim and that JT valve, keeping it clean. It's really important the kind of pressure sensing mechanism you have, whether it's a Fisher, you know, 4160 or a Kimray or whatever you have to make sure it matches the kind of JT valve that you're using. And the trim size is so important. You get too big of a trim, then it's just going to pop up and down instead of holding a good 40% open and letting that JT process happen.
Yeah, and that is a good point, because if you're getting those fluctuations, then you're not getting a real consistent temperature operation. Because if it's opening and slamming closed and opening and slamming closed, you're not going to get a nice consistent process for it, which is gonna wear the valve out more and cause other operational problems. But yeah, if you can maintain that as consistent as possible, which maybe it means getting a better pressure controller, more like a Fisher or, you know, the North Seal knockoffs of them, instead of just, you know, the Kimray Pilot, which is, you know, super easy to use and nice and simple, but those do have a, you know, wider band on them that they operate within, compared to the other controllers. One thing about NGL recovery, though, I mean, there's only so much you can get out of it, and you're not going to remove most of the propane until you're below -20. So, you know, some people, they're just like, you know, I want C3 plus everything gone out of it. But without, you know, unless can get super, super cold, then you're not going to get all that stuff out of there. And you always will have a little bit of some of the heavies left in there. I mean, you can neutralize pretty much like hexane plus, but you're still going to have some butane in there, some propane. Even if you're operating a -40, you'll still have some propane in there.
Make sure you have a throttle trim in the JT valve rather than a quick opening trim.
Yeah.
That's really critical.
Yeah, especially on the smaller fuel skids, you see them a lot. They just go with the dump valve because they're like, oh, I only need a 1-inch valve. So they just get the normal 1-inch valve that they're used to having, and most of the time it's a quick open separator valve instead of an actual throttling control valve like they should be getting. And then separation's been pretty good too. I mean, just any separator, a lot of the fuel skids, like they oversize them because they want to have the liquid capacity to be able to take a big old slug. But if you oversize your separator, then you're hurting your efficiency of your separation. If it's too big of a separator, then that mispad's not going to do what it's supposed to. And when you're making the gas cold, you're creating a fog inside the gas, and a lot of it'll start to condense immediately. It'll collect as bigger droplets and fall out, but you need a good mist pad that's properly sized in that separator. So oversized equipment on JT, you can lose some efficiency in what your removal is. We've seen that on what the simulation doesn't predict what it should be doing, because the JT is like a 10 million JT and they're barely doing 1 million through it. And it's just the separator is just so big that the performance is actually much worse than what it should be, because it just wasn't sized for that. And in that particular instance, it was a vane pack, which is a little pickier on the operating parameters for it. But yeah, knowing that, you know, the system is really operating within the conditions it's supposed to can improve that efficiency.
Well, they had a follow-up question. I'm going to put it now. I guess the NGL recovery, they're talking about LNG and CNG. What is needed, what is needed to process from your experience? Dehydration. Chris, we've done a few projects on the CNG side. Before it goes into the trucks, can you talk about that experience?
Yeah, CNG is a little easier. The risk that you're trying to avoid with CNG, you definitely don't want anything corrosive going into the tanks and then obviously ending up into whatever you're using it for. But you don't want any fallout in the tanks or when you're depressurizing from the high pressure to low pressure with those CNG tanks. Typical CNG pressures are 3,000 to 3,600 PSI. So that's a big pressure drop that thing's going to take going out of that tank. So if that gas is too rich going in there, then you can actually get from when you compress it up, if the compressor doesn't have the right aftercoolers and separators, you can actually end up with liquid in those tanks, and which would just defeat your capacity of the tanks if too much of it builds up. Same thing goes with dehydration. If you're not dehydrated going into that compressor, when that compressor gets you up to 3,600 PSI, that gas at that pressure can't hold that much water anymore. So you're gonna have water fall out. And if the separator, if the compressor's not separating it like it's supposed to, then that ends up in those tanks. And then if it ends up, you know, depressurizing into their, the depressurized, like usually it's a heater that they depressurize through. And, you know, if that water hits that, then you'll just get a hydrate and freeze up the whole thing. So it is important. Usually pipeline spec's good enough for CNG. So if your equipment's getting it to pipeline spec, then it is good enough to put into a CNG process. LNG is a different thing. LNG, you got to get all the CO2 out, because the same way we have problems with, you know, the reason we dehy to not have hydrates with water, with LNG, you'll have CO2 will turn to solid. You'll get dry ice chunks in it because of the temperatures that LNG is operating at. LNG has to be very, very clean gas, basically eliminated all the CO2, and you're talking like 98% methane with, you know, hardly any ethane left in it as well.
Is there anything y'all want to add to that, Jesse or Terry? Because we have time for one more question. Okay. All right. So this is a big one, but Terry, this is for you. This is, or if you could take the lead on this one, it says, we are moving an old TG unit to a new field that has very rich gas. Is there anything that needs to be added or changed on it to make it work? The unit is standard handover, which you should have experience on that. Handover unit, but the field it was in had very lean gas, and the operator's concerned that the different gas will change how it operates.
Well, that's a good question. It actually shows that you're thinking ahead of time. You're moving this unit, and you're aware that there could be some issues. The first thing is the unit was designed to operate at saturated conditions. So no matter, you know, what the condition is now or what it will be, water-wise, you're going to be fine. Now, when you're talking about rich gas versus lean gas, that's when we're going to get into possibly pre-treating to remove those NGLs from the stream to lower that BTU of gas before it gets to the dehy. And that's where, you know, like guys at Croft could put something in front of it like a JT skid or, you know, something to manage the BTU. Now, when you look at the dehy itself, the first thing I'm going to do is clean it, because you don't want to carry your contaminated issues to the new location. Because when you lay that tower down and put it on a truck and you stand it back up on the new location, you're going to have a lot of organics and solids and stuff break loose from the vessel walls and in the tray and packing, you know, and the fire tubes and stuff. You're going to have a lot of solids that are going to plug the whole system up when you start it back up. So personally, I would want to chemically clean it and clean everything and then drain it, make it ready. You also have DOT regulations you got to follow. You're hauling pieces of equipment down the highway. You don't want glycol and hydrocarbons coming out of it. So you want to clean it and flush it before you ship it. And if you have really rich gas, you want to make sure, I know a lot of the old Hanover units, the older ones did not have charcoal filtration or charcoal absorption on them. Mm-hmm. I would want to add a charcoal canister to that skid, like an 1122 charcoal canister, so that when that glycol picks up those hydrocarbons in the contact tower, because now you got richer gas, it's going to be saturated not with just water, but it's going to have a lot of hydrocarbons in it. you don't want that getting in your reboiler. That puts a lot of load on your BTEC system downstream. So that's all it counts for emissions. So if you can, you got to make sure your pump gas separator is working properly. In your lean gas application, you probably didn't make a lot of hydrocarbons in your flash gas separator or your pump gas separator. In a Hanover unit, I don't know what size this is. Smaller one, that's a little separator that's on top, or it could be a vertical vessel off to the side with the bottom insulated. It has 10 different names, but it's just a 3-phase low pressure separator separating glycol, hydrocarbons, and gas. So there's only 2 places that are in the system of the regeneration unit, the glycol system, that's designed to remove hydrocarbons. That's the pump gas separator and the charcoal filters. So when the glycol dumps out of the 3-phase pump gas separator, going back to the reboiler, it normally needs to go through a charcoal canister to absorb what's left in and trained in the glycol. So when the boiler receives the glycol, all it has to do is flash off the wire. Remove all the filters. Before you shut the system down, test both pumps to see if they work. Yeah. Because one of them, if it's a standby pump, probably got switched over to the good pump and the first one was never repaired. Yep. So just going by historical data here, guys. You know, if it ain't broke, don't fix it. You know, crash mentality we're in right now. So test both pumps and see if they work. If not, then you know, because the guys that are receiving that unit charging.
Uh-oh. Terry, we lost you. Well, Jesse and Chris, did y'all have anything to add to that?
Yeah, 2 big things on different ends of the glycol unit that I would say. I know Terry definitely pushes it real hard. Is inlet separation has got to be real good.
Is location. If not,
oh, there he is.
Oh, did we lose it?
I'm back again.
But yeah, inlet separation is super important. If it's rich gas, I'd say you basically need to have a coalescing filter ahead of it. The inlet knockouts it's on a contact tower, they're like in a lean gas application, like where this thing sounds like it's coming from, that thing probably never caught any liquid. But for rich gas, I mean, a good coalescing filter, preferably reverse flow, submicron, like a real coalescing filter, not just a filter separator. I think you really need to have that ahead of that unit just to make sure, and then maybe a separator before that, just if there is liquids that are going to be slugging into it. And then the other thing is on the other end of the unit, if they have a BTEX unit, if it's got the kind that re-injects the gas into the burner, the operator better know what he's doing with that, because I'm sure Terry's got tons of stories of those things catching fire, and it's always rich gas applications where the hydrocarbons made their way to the reboiler and then overflowed into the BTEX and shot back into the fire tube, and then you shooting flaming gasoline everywhere.
You really had some brilliant points there right at the end too, just so everybody knows.
But yeah, I mean, I think if you have to have a BTEX and it's really rich gas, I would look at maybe putting a separate combustor running that gas to not the burner on the glycol unit, because that's a big risk, fire hazard to do that.
Well, that's the end of our questions right now. So what I want to do is, it's been an hour, but if we're going to wrap it up. If you're interested in being a webinar speaker or know someone who wants to be is a good fit, please reach out to us. Let us know so that way we can touch base with them. Whole purpose of this exercise is to share knowledge, to talk to the subject matter experts that's going on. You will be getting a survey. So remember, this is our first roundtable. So we're really, everyone that's on this call, on this webinar, we're really looking for y'all's advice on how can we make it better, longer, shorter. more pointed questions. I only want to hear about glycol systems. Please, just let us know about what you're wanting to go through. We're going to make this a monthly roundtable discussion to only focus on questions. So if you have any questions outside of it, reach out to us. If you had any particular questions, please let us know so we can get it prepared for the next time that we hold this thing. So I'm going to stop sharing. But Jesse, Chris, and Terry, thank y'all so much for taking the time. Y'all devoted a lot of time to this, and I appreciate y'all's effort in doing this.
Well, you're welcome. I think, overall went pretty well. I think having those preloaded questions helps. We'll probably get a little bit more into detail, but overall, I think it was good.
Yeah, that's one thing we're trying to do is how do we increase engagement. We really want, thank you to the participants that, on it, we're asking the live questions as we were going along. I mean, this is y'all's time, so any pointed questions we're here for you. But we're gonna make this a monthly basis, and then we're gonna be shipping out invites to y'all, reaching out to you personally. So we're gonna wrap this up, guys, and if any of y'all have anything left.
I appreciate it.
Absolutely. All right. Y'all take care, and thank y'all for everything. All right.
Thank you, Cameron.